course. This is a highly coveted spot. I get to lull you guys back into technology and the amazing things that we're doing here in Amazon. So thank you for coming. I know you had a lot of choices, probably sleeping in, and I'm delighted to be presenting to you today. By way of introduction, I'm Steve McPherson. I'm the Senior Manager of Amazon Elastic MapReduce. I was a customer before I came to EMR. In 2009, I was the Director of Technology at Razorfish Publicis, and I had a team of 35 engineers that knew almost nothing about Linux, Hadoop, or cloud computing in general. We ran our business off SQL Server cubes and Microsoft Excel pivot tables, as most businesses do nowadays. But we had a campaign. It's a digital advertising shop. We had a campaign that was going to push us to process more data than we'd ever done before, on like an order of magnitude. And we were losing our infrastructure. We were just purchased. We were a Microsoft shop, and then we were purchased by Publicis. So we were losing our infrastructure altogether. And it was this perfect confluence of bad things. And it was, I had to figure out what I was going to do. So I found Hadoop, and we got up and running with it. We started experimenting in the platform. And in the course of 3 months, this team that had no context or no knowledge of Linux, Hadoop, or cloud computing at all was up and running in production, running 45 terabytes of data a day. It was transformational for me to see what you could do in such a short period of time with people, just getting up in a very complex domain. How many of you guys are familiar with Hadoop in the room? Great. How many of you guys are customers of EMR? Okay, good to know. So for me, that was a transformational experience to see what can happen in a business when you can give people the tools to take away all the cruff of the infrastructure of it. And since then, in 2009, like Hadoop itself, Elastic MapReduce has evolved from being a job flow batch processing engine into being a generic Hadoop cluster manager service with a diverse ecosystem of Hadoop applications. And I'm going to cover some of that stuff in this talk. I'm going to get into data warehousing and some of the thinking where we see most customers getting leverage out of the cloud and being successful with the Hadoop ecosystem of applications. And then I will be available afterwards for taking questions if anyone wants to go deeper on anything I've talked about. So regardless of the business that you're in, it's important to be able to obtain information based on analysis of data coming from any number of sources. And you need the right tools to do that at scale. It's helpful to look at things in terms of a traditional data warehouse, just to kind of give words for things. On the left-hand side in this diagram, we have ETL. ETL has the job of taking data from where it's at in some form, probably for some very good reason, like it was written there from a web server, and that's how it's ought to be. Transforming that into something that is a well-formatted schema or something that your business can make sense of for downstream tools. That's the left side there. On the right side, you have reporting and ad hoc analysis and things. And this is typically the domain of where humans are asking questions. In the center, you have this thing that is sort of this monolithic entity called a data warehouse. And I say monolithic because it mixes the responsibility of bulk data storage, schema definition, and query execution. And when you look at where you get caught up in your data warehousing, it's because those things are bound. It's not necessarily because the engine's good or bad at these things. SQL is great for doing querying. And so all these data warehouses that use SQL, that's good, because humans like SQL. It's a structured query language. It's not necessarily bad that they are how they go about storing their data. It's bad that they're both storing, and they're the guy who's storing it, and the guy who's going to be doing the compute on top of it. So when you can break these things apart, you get a lot of power. And software frameworks like Hadoop can help with this. It does it by distributing the storage of the data to many computers, and it also then distributes the compute. So you can have your data stored independently, and you can scale up and down your compute resources. I'm going to get into EMR for a second. The project itself started from an open source community of developers working specifically on a distributed batch processing engine. It evolved from that to be generally a moniker for all of the open source big data projects out there. So it used to be that Hadoop meant MapReduce. It no longer means that. Hadoop now means everything from HDFS to Storm to Impala to what have you. It's a general term for open source big data. With Amazon EMR, for those of you that are not familiar with it, using the elastic infrastructure of EC2 and S3, Amazon EMR provides a managed Hadoop infrastructure. EMR takes the work of setting up Hadoop that is specifically deploying the bits to it, managing nodes, and making those, managing the lifecycle of those, and then also we take on the responsibility of making sure that the bits that are running in there are good and efficient as they interact with S3 and the other AWS components. So where we had traditional warehousing in the past, I didn't necessarily go into the slideware of tools. You can imagine all those. They range from scripts, shell scripts and all these things to very sophisticated drag and drop transformation things. In the Hadoop world, you can kind of see some of the tools in the ecosystem. Here I have my, and on the extract side, you have the MapReduce APIs. You have frameworks like Scoop. In the transform section, you have any number of languages, and there's probably more languages than I even know about out there. But Spark, Cascading, Pig, MapReduce itself. In data warehousing, I'm putting that center section in there to call out some file formats and just kind of generally say that it's important to recognize that the storage of the data, it's a logically separate part from all the other bits in there. And so there's good investment in technology in the community with file formats like Parquet and ORC that are able to take this notion of columnar storage and actually make that available to many technologies downstream. So for example, with Parquet files or ORC files, you can get very good benefit of storage when interacting with Hive or interacting with Presto or any number of other tools. So again, decomposing these monolithic blocks of what a data warehouse is and what the different functions of it is handy when you have all the parts kind of on the table like that. On the right-hand side, where it would be the humans asking the questions, you have frameworks like Hive, again, Spark, Cascading, Pig. This is, Pig and Cascading are typically thought of in ETL, but people often will also use them for report generation because it's handy, right? You have code and you can debug it and test it and things. And then on the right-hand side, you have frameworks now like Impala, Facebook Presto, which is a fantastic tool. I'm going to show some of that later on. Hive, Spark SQL is now emerging, and Cascading Lingual. So as we go from left to right, the ecosystem of tools that you might have used in history, there is a component in the Hadoop world that can help you with that. In this diagram, I have specifically Amazon S3 at the center. Normally, when people think of Hadoop, they kind of just as quickly go to HDFS. And HDFS is great. It's really very good. One of the unfortunate side effects of it is that when your HDFS is your cluster, when you were defining your cluster as the machines that host your HDFS, you then no longer can separate your compute from your storage. You're kind of stuck with this thing. If you want more if you want more storage, you have to buy more compute. And so you end up having these these clusters that are irregularly balanced as a business grows, and you get this massive data storage, and you have all this compute sitting around for no very good reason. So for storage, most of our customers use Amazon S3 as their single source of truth. It is their data lake. Amazon EMR has optimized the Hadoop components to work with Amazon S3 as their native storage. The tight integration with S3 allows customers to scale the storage independently of the compute. It removes operational burden of HDFS. It ensures high durability of the data. It provides universal access point for multiple clusters to read the data itself. So you can have one cluster that's an ETL lifecycle, so every night it needs to get something done in 3 hours, and there's no fuss, no muss, just get it done. And then you have other workloads that may be more analytics. Somebody wants to run a tool like Tableau and do analytics through some low latency query engine. So having S3 as your back store, where in HDFS you can actually quickly get to contention, where there's only 3 guys out there that have the data. So the request is going to go to one of these 3 guys. At heavy load, S3 does not have that same contention problem. S3 is essentially spinning disks that have extremely fat pipe to all the nodes in your cluster. So you can take benefit by having that storage off the cluster. I'll also point out that S3 is very low cost. Prices have dropped 7 times since the service launched in 2006. It also integrates with Amazon Glacier for even lower cost. So where storage gets cold and you don't need it around anymore, which is probably the bulk of your data after you've done your normal processing, you can easily ship it off to Glacier. So storing data in S3 allows users to spin up as many clusters as needed to test out new ideas and to terminate clusters when they're no longer in use. That speeds up innovation, it lowers the cost of experimentation, and it also allows you to tune clusters for their particular use cases, as I was describing before. With EMR, you can run custom MapReduce code written in Java, any of the frameworks, or you can utilize any of the open source technologies like Presto or HBase or Spark. All of these are available to you in Elastic MapReduce. It's a very rich environment for you to configure. Using Amazon S3 as your storage also provides sort of business continuity out of the box. If you, I just recently had a customer meeting and they were going through their DR planning, big company, they had legitimate concerns on they can never go down. And coming from a world where they're planning all their Hadoop work in their data center, they're thinking that they have to go build this massive infrastructure like to sit there warm and just kind of do nothing with just for the sake of DR, and they do all this data replication and all this noise. In fact, Elastic MapReduce, because you can spin up clusters in any availability zone, and if your data is in S3, it really isn't a problem. If your AZ goes down, you have another cluster, you can spin up another cluster in minutes, and it's pointing it and has just as good and just as high throughput access to that data as you would in the other AZ. So that's another handy benefit that you get from breaking these two problems up. It's easy to get started with Amazon EMR. You can load data from S3, from DynamoDB, from Amazon Kinesis. And in 3 minutes, you can get up and running and start querying the stuff. I'm going to show you that in a second. You don't need to worry about setting up the cluster or tuning it or babysitting the machines. In the Hadoop world, how many of you guys have ever operated a Hadoop cluster? Did you want to? Like when a machine... Okay, that guy does. Good. Well, you can do that too. The good news is you have root access, so you're set. So I'm going to show you some demos now. So here I am. I'm at the Amazon Elastic MapReduce console. Many of you guys have already seen EMR, so this is going to be a bit of a review, but you came to church, you're going to hear the gospel. That's how I see it. So here we are. We're sitting on the console. It's very simple. These are my running clusters here. I can go check out the status of them, see how many machines are in it, see the bootstrap actions that were deployed on it, see that they're running. So that's all great. Now I can create a cluster too. And just for simplicity's sake, I'm going to take my contextual advertising bit here. I'm going to change that. Handy integration here. So there we are. We have our cluster. It's all well defined. You can see in EMR, we very rapidly put out new bits. Almost monthly now, we're actually deploying a new build of Hadoop in the ecosystem of applications out there. To the point where it's actually getting a little tiring to see new stuff always popping up. We need to condense this menu here, make it a little easier. So there's rapid adoption of new technologies as they come into the ecosystem. Another area that you will see a lot of innovation in, certainly in the last year and going forward in the coming year, is very, very deep integration with S3 and all the capabilities of S3 as they emerge. So native support for server-side encryption. We are pre-announcing integration with key management service, which enables client-side encryption. And our implementation will allow you to either use the key management service or yourself to manage the keys in a custom implementation. That is something that's going to be coming out quickly. We introduced a consistent view of S3. So one of the things where S3 is sort of troublesome in the Hadoop space is that it's not a file system. As much as we try to pretend it is in many cases, it's actually not a file system. It's a blob store. And as such, it has some problems with doing things like listings of massive buckets. If you have billions of keys in there, it also doesn't do file appends. And there's a lot of things in the Hadoop ecosystem that want to do a file append. So that's where most of our work in the Hadoop bits actually where we customize it. In general, we work very hard to keep as close to Apache, the Apache code base as possible. And in the last year, we've been pushing an awful lot of our changes back to open source as we've gotten more bandwidth to do that. So our intention and what you can sort of expect from the EMR team is that when you're using something that says it's Hadoop 2.4, it's Hadoop 2.4, and nothing fancy in it. Other than that, we've made it work. So we're less interested in trying to be authoritative and have some distribution, but we're very concerned that people who run in EMR have a seamless experience with interacting with S3, interacting with Dynamo, interacting with Kinesis, and all the other big data services. So we added also a feature in recently for consistent viewing. So another place where S3 has some difficulty is that it's an eventually consistent system. So the impact of that is in MapReduce job, if you have something that's cascading one job after another, let's say I write, I do some aggregation or I do some fancy thing that's going to convert my logs into a format that's going to be useful for a guy downstream. A logical operation for an ETL process is going to be one thing and then one step that goes to another step that goes to another step. And in a consistent file system or file list, that's great. In HDFS, it's designed that way. In S3, when you're, it could, in USD's classic, it could be the case that you don't get get after put consistency. I put it in a file and it doesn't show up. And if I did a listing on that directory, I wouldn't necessarily have it. It's actually not as big of a problem as you might think, but just in reality, people have gotten burned by that. And so they historically have had to do things like manage a manifest file and things that are just kind of awkward. So this feature with consistent view takes care of that problem. We manage an index in DynamoDB on your behalf that checks in every file when it's written. And so all the operations that are meaningful in that space, all that stuff is kept in DynamoDB. And the other side effect of this is that we get very fast listings. So that other problem I was telling you about with S3 being a dog on billions of records or billions of keys coming back. Because of that integration that we built, and because of that manifest we have, we're able to sort of predict where the key space is going to be, what the key space is going to work out to be in S3, and so we can provide very fast listing of those directories, and at the same time discover new files as they come in. There's been a lot of work with people that have there was a project many years ago, it's kind of died off, called S3B, that took the approach of just putting the blocks in S3 and keeping the name node doing its job. Some of the problems that we found with that is that people actually like S3. People want to use S3 because that's where their web servers are dumping their data at. That's where their Bodo client is going to read from, all these things. So we do an awful lot of work to make sure that S3 as it is works very well. And you'll see more and more features and focus from our team coming through on that. So in this screen, you can see that I can set up all my machines. I can provision the network for VPC and so on. And I'm off and running, and I can go and create my cluster. Is there anything else in there I'm missing? So we're off and running. So boom, 3 minutes later, we're going to have, ta-da, Hadoop. So you don't have to go learn Linux and all that stuff. You can actually just get up and running. So cool, we're going to do that. I'm going to skip over to something which is a cluster that I started up maybe a couple days ago in preparation for this talk. So I think it was last Friday, we released Hue. Hue is an open source project that is the Hadoop user interface. It provides a GUI for Hive and Pig and Metastore. I'm going to show you those features. we're very excited to announce that, and some of the things that we added into this, I'll show you in a second with S3 integration. The thing that I'm very excited about with Hue is that previously, I've lost personally an awful lot of time trying to figure out SSHing into the machines and going there and just all the goo of the interfaces of Hadoop, be it through Hive or Pig or what have you. It's actually kind of a crap experience to have to go SSH into things. And now you have this very, very intuitive, almost like SQL Server view where you can actually just write sensible queries in it. So the basic Hue experience, before I get ahead of myself, is as you would probably expect a UI of Hadoop to be. When you jump into it and you launch it for the first time as a user from EMR, you're going to find samples that will be handy for you as an AWS user. And we also think that this is a good way to kind of train people on how to use the tool. So if you're not very familiar with Hive itself, we can help you understand what Hive is doing and its notions by giving you some sample queries that you might actually want to query. So in this case, I think I'm looking at the CloudFront logs. And if I want to do some sort of analysis on it, you can see it's very simple. I signed into Hue. I have my sample here. I'm going to create a table for CloudFront logs. I'm declaring those types, just like you would columns in a database. I'm informing it how that's stored. So I'm doing a regular expression to actually extract these columns. And then I'm pointing it to the location in S3. So I'll go ahead and run that. And now that is created, let's see. Yep, CloudFront logs over there, great. We can now do a select against that guy. And it's Hadoop, so he's going to spin up his jobs. He's going to look at all the files that are there. He's going to calculate his splits. He's going to figure out who needs what data. And then he's going to go start executing that job for me. And I think in these samples, they're generally fairly small data sets, just so you don't get bummed out with all the work in it. But in this, one of the big problems that we find people have when they try to use Hadoop is that it's really painful to debug Hadoop. If you need to go get to your logs, if you need to figure out what's happening, the point of the system is that it's going to distribute your work across many nodes. So if you're the guy who has to go find those logs, it sucks. So within Hue, actually, it went past my screen here, but I have it here. You can see handy links in here to actually get you to all the meaningful logs as they occur. So if you get an error, you can actually find it. And if there's a specific error log, it'll actually link to it, and you can pull it up in your browser. Let me see if I got one of those guys. Anyway, and then, of course, your results. As you would expect, you get them back, and you can have them handy and work with them. And there's some primitive charting in there if you want to take some dates and put in there. He's laughing, so clearly he doesn't think that highly of that. OK, so now I'm going to show you Pig and some of the functionality in that. Again, we'll go back to our samples here. So you can see Pig is a different language. It's actually meant for ETL itself. It's not meant to be sort of an analytical or report generator thing. It's actually meant to move and transform data. So it has a different language and different syntax and so on. So I think I'm good to just run this guy. In this one, what we're doing is we're looking at Apache logs, and we're going to generate some statistics off it. I think I'm looking at maybe browsers or doing it by time. But in any case, let's go ahead and run it. So the same sort of user interface that you had with Hive, which was a SQL environment where you wanted columns and rows and a structured query. This is much more the style of an IDE where you want to actually debug something. And when you're writing it, you get handy things like autocomplete when you reference files and so on. So again, I'm streaming back my logs as they come through. This is actually looking at a slightly larger data set, so we'll continue on in this talk. I'm going to go over to the file browser really quick. So normally, Hue is very focused, as Hadoop is in general, on its own, internally, right? It thinks it's a cluster in a data center somewhere, and that's great. But EMR says it's not. You're a cluster in the cloud, and that means different things. So one of the things that we put into it is actually a S3 file browser, and we're actually kind of proud of this. I think arguably this thing is better than what you might find in the S3 console UI in some ways. I say that because, let's see what I got here in my logs. I'm going to try and find one that's relatively small. So I can read the files directly in here. And I can actually interact with these files as though it's an interactive web console for a file system. So and we will be continuing to add more and more capabilities to this, including you'll notice that we have edit file in here. So one of the guys on the team proposed that we might actually be, people might be spinning up Hue just so that they can actually interact with S3 because the browser here. So that's pretty cool, I think. Another thing that you might be concerned about in your Hadoop environment is job history. The Hadoop tooling, even in Hadoop 2, there's been good improvements in the UX and things, but Hue does a great job of putting all that stuff in a sensible manner so you can actually, in an attractive UI, so you can actually go and figure out your jobs, the status of the jobs and what have you. So you can dive into those things. So I'm going to change pace a little bit now. So I've talked an awful lot about how to use EMR as your Hadoop infrastructure, about S3 as your storage system. And now I want to talk to you guys about emerging capabilities in your using EMR as your data warehouse. Your data warehouse can also read from real-time streams as well. So early in the year, when Kinesis was launched last year, EMR put out a connector that makes it so you have native connectivity between all of the Hadoop ecosystem applications and Kinesis as well. So I'm going to introduce you to that and show you a demo of it, but just to kind of to talk through this and put it in the context of the Hadoop ecosystem, I'm going to talk for a second. So on the left-hand side, you have this is the data flow, a typical data flow that you would see in a continuous processing engine or in real-time stream. On the left-hand side, you have clients or sensors, things that are going to be emitting events or facts into your ultimately what's your data warehouse. You will typically have something that's a recording service. So there's going to be some endpoint that the clients who are emitting those things have consistently to go drop off that data. Within that infrastructure, there has to be someone who's going to take that information because time and physics is different to different entities. So it has to be an authoritative source for aggregating and sequencing data. So that responsibility is there. After that, you have the opportunity, once it's sequenced, to do something like a continuous, to inject something like a continuous processor. Apache Storm, Apache Spark streaming, all very good tools for this, or even something like Esper, a complex event processor of some sort. After that, so that opportunity is there. It's not necessarily the guy who's going to put it into your data warehouse, but you would do it right after this aggregation sequence if you want to get those real-time streams. Then the data is ultimately stored in your data warehouse. It is persisted somewhere that is reliable and is going to be permanently accessible. And downstream from that, you're going to have your analytics, so tools and reports and these sorts of things. In the Hadoop ecosystem, the tools that are out there look something like this. On the left-hand side, you have your kit that you write in. There's nothing particularly interesting about that. But in the recorder aggregator section, you have things like Kafka and Scribe and Flume. And they have their own features, and they have their own attributes of scale that they work in. And then when you get to the right-hand side, in the Hadoop ecosystem, there are things like Storm, as I mentioned before, Spark. And as you push further over there, you find the canonical applications like Hive and Pig and Cascading and Mahout and so on. So Amazon Kinesis is a managed service that scales elastically for real-time processing of streaming data. Customers can write large streams of records from any client over a standard web-accessible API. The service ensures monotomically increasing sequential ordering of records as they stream in, and it makes it available to downstream systems for processing. So if you look at the ecosystem I had a second ago with all those other tools in there, it's kind of a soup. If you look at this from a hosted perspective, to just reduce your moving parts in your infrastructure, you still have this notion of a client that has to write into Kinesis, but the team made it really easy to do that. We wrote an appender for Log4j, so you can just actually stream your messages from Log4j directly into Kinesis. So you don't have to think about the client implementation of it necessarily. Kinesis then is your streaming data repository, and downstream from that, Amazon EMR with the diversity of tools that are available in it can process your data. So in practice, it might look something like this. You have a dude in a fancy suit like me who he writes an application, maybe hosting Elastic Beanstalk, who emits his data through Log4j. It's pushed to Amazon Kinesis immediately. Then for the purpose of analytics, and when you want to aggregate these things, using Amazon Elastic MapReduce, you can actually join from any number of different data sources. For example, in this case, DynamoDB as well as Kinesis, to join that data and then ultimately persist it to S3 or do some sort of interesting processing that you might want in there. It's interesting, or it's important to note that there's many different implementations in the Hadoop ecosystem for interacting with streaming kits. The implementation that we have between Amazon Elastic MapReduce and Kinesis is there's two sides to it. One is the Hadoop input format, which opens it up for processing in any of the Hadoop ecosystem apps, so cascading, Pig, and so on. And then there's a discrete implementation inside of Apache Storm itself, Spark Streaming itself that actually interacts with Kinesis. You can get much faster iterations on it. So putting this into code, what this would look like is I have my Log4j appender just writing directly to Kinesis, and then on the other end, I write a SQL query. So I'm going to do a demo now. I can't see that. So. All right. So what you see right here on the screen is I have an application that is using. Sorry, guys. No. Stand by. Okay. In this screen right here, I have an application that is specifically just pushing data to Amazon Kinesis. Yeah, that's it. So this code is actually available on GitHub right now. If you are interested in seeing that, you can pull up this application. It'll read files and it'll directly stream it in. I'm pointing this out to kind of show the end-to-end scenario here. As I go into my query editor, I can, sorry, stand by. Now that I am in Hive, in this fancy UI, I can define a table against Kinesis just like I did against the S3 tables. So you can see in this where before I created those columns as though they was against a file system. It's the exact same definition of columns that I have when I'm interacting through this implementation anyway, when I'm interacting with Kinesis. So we take away all that overhead there. The only distinction here is that we're saying that it's actually stored by the Amazon Kinesis storage handler. So after you have that in place, which I do, you can do a direct query against it. Is that good? Any typos? I think I'm good. Okay. So just like I had data that was coming back from querying a file in S3, I now will have data coming back results directly from Kinesis. So if you use Log4j or use any of these other messaging systems, or if you just want to write directly to Kinesis on your own, the overhead of doing end-to-end processing in a real-time fashion is very light. That really is all that you have to do right there. Hopefully your monitor doesn't crash on you when you try to do it. Now we will go to, I'm going to change pace again, and I'm going to show you, I was talking earlier about Amazon Elastic MapReduce being hosting the diversity of the open source big data technologies. We are early adopters of those technologies. We initially sort of announced interaction and support for Spark almost a year ago with an article that we did. We are continuing with that. We'll expose it on the website for everyone to do very quickly, but within EMR you can launch Spark clusters, get them up and running, and start experimenting with that. And we have customers today who are doing that with great success. So within this, I have a cluster that I defined here in EMR that I brought up. I think I'm looking at it right now. So very simple. We have a bootstrap action that actually goes and installs Spark on it. And then from there, you can SSH to the box as I am here, and you can start doing processing against it. Now, I want to show you a demo of Spark SQL. Spark SQL is sort of analogous to Hive in the MapReduce world, in that it is taking SQL syntax that you might write, and it is then converting that and doing code generation to create the appropriate code for execution in Spark. So here I am. I have a query that I'm going to run. It is pointed at Wikipedia statistics data directly on S3. So again, the point of EMR being a warehouse is you don't have to take that data and do all this massive conversion to go finically put it into another system. You can actually take it as it is and start processing it directly. Did I get an error? Has that happened? That worked, I think. No, it didn't work. All right, let's get that. And then similarly, to that same point of new tools that are emerging, we have Facebook Presto. Facebook Presto is a very exciting new technology to come out in the Hadoop ecosystem. Again, I was talking to you guys earlier about having the ability to break off your storage, your definition of your data, how you interpret that, and where it's stored and where it's executed. In Elastic MapReduce, when you're running Facebook Presto and you use it against S3, you have sort of the perfect confluence of technologies there. It is a RDBMS. Like it's not a funny thing where it's going and doing code generation and fancy stuff. It's purely a machine for doing low latency querying. It's an in-memory database, and it works well with the Hadoop ecosystem of applications. Specifically, it works well against the Hive metastore. So where I have a table defined in Hive, I just did in Hue, as you saw a minute ago, I come into Facebook Presto, pointing directly at S3. I have a cluster up and running, and it's able to query against that. So a query that takes in Hive, the same query will take about 5 minutes, partially because it has to go do the code generation, it has to schedule it with an engine, and then execute that. In Presto, that's a very quick process. Also, it is an in-memory system, so there's the process of actually streaming the data into the nodes, and then after that, everything's sitting in memory and resident in that. So we have customers that are using Facebook Presto right now and having good success with it. The key point being that they can leave their data directly in S3 without having to move it around or transform it and put it into some other technology. So in Amazon Elastic MapReduce, you can leave your clusters up and running. Another sort of conception that people have about Elastic MapReduce is that it's purely just a job flow engine, and it is a wonderful job flow engine. And you get a lot of power out of having a job flow engine if that's how you want to interact with it. The idea with the job flow on the right side there is that I have some predictable work that I want to get done every night. It's my ETL. It may be coming from Kinesis. It may be coming from Kinesis not every night, but like every 15 minutes or something like that. But it's predictable. You know that it's going to be there, and so you want to schedule that guy and continue to run him. Elastic MapReduce will spin up the cluster. It will manage the lifecycle of the cluster. It will get your job done for you. If machines go down, it will replace those machines, and it will drive that job to completion. So it's very powerful in that use case. Many of our customers, beyond that, actually want to interact with Hadoop. They have infrastructure that has a known or named endpoint that for shared, as a shared business resource, something like Facebook Presto is there that they want up all the time. And so in that case, people will, just like they would in an on-premise installation, they'll spin up an Elastic MapReduce cluster and leave it up and running for a long time. The thing to know about that that's really handy is you should still consider that you can consider those clusters long-lived, and they are a known resource and so on. But the other thing that's really handy there is that when you want to do deployments to your cluster, like let's say you want to take a patch to HDFS, or you want to deploy some configuration change, you can you can actually spin up a secondary cluster right next to that, and you can to kind of test out your new cluster. You can move your traffic over there sort of gracefully, and as the traffic moves over and you know that environment is really stable, you can actually shut down your old one. Netflix calls this their red-black push, and they do it in their business. They've written pretty extensively about it. That's a very handy approach because it's just like a load. It's like conceptually like a load balancer or something that you can divert traffic from one place to another and continue working without interruption. Amazon EMR also integrates with your traditional BI tools. We also support other distributions. MapR is a great example of that. MapR is a partner of ours. And customers who might be running MapR in their data center who want to move to the cloud can actually deploy clusters with the MapR distribution itself. Also, the large analytics and Hadoop ecosystem applications all run with EMR. We recently announced support for Tableau. We released our ODBC and JDBC drivers, and on our big data blog, you guys can find an article on how to directly connect Tableau to Elastic MapReduce. We also recently announced support for Splunk, specifically Hunk. Customers can deploy Hunk and have it pointed directly at EMR customers to interact with that. And today we are announcing Looker, support with Looker. If you go to emr.looker.com, you will see a demo. You'll have a demo environment where you can actually interact with Looker as it works with Impala on an EMR cluster. EMR is flexible and it's cost-effective. As with the rest of the EC2 environment, you're able to leverage the EC2 pricing models to really take advantage of scaling your data warehouse. So there is the traditional on-demand pricing that you can get, and it's very intuitive. You can also, if you know that you are going to be doing repeated work, and you can schedule that, you can budget it, then it often makes sense for you to buy reserved instances, and that can dramatically reduce your price when interacting for your data warehouse there. And then the other thing that a lot of customers are, a feature of Elastic MapReduce is that we support spot instances. And spot instances in EC2 are actually kind of troublesome. It's great because you can get them for pennies on the dollar. People save a heck of a lot of money using spot instances. The problem is that you have to write your applications in a way that they can fail. The instance can be reclaimed from you at any moment if the spot price goes above that and the system wants that resource back. So you have to get this amazing benefit of price, you have to write your applications really cleverly. It turns out that Hadoop is already written that way. It's very pessimistic. It doesn't trust anything. If a job's taking too long, it'll start up a job on another machine in a process that it calls speculative execution. But in general, the whole idea of distributed computing fits really well in this model where you can take a problem, break it up, go through it at a node. If it dies, it's fine. I'm going to replace it with another node, or take that job and schedule it on another node. So EMR supports Spot instances in a cluster. And best practice here is don't ever use Spot for your master node. Please, don't ever do that. It's very disruptive, and it's not good. But so don't do that. But typically, customers will buy reserved instances to kind of handle their traditional load. And like think of on the worst day, on a rainy day, what is it going to take to get this job done? And buy reserved instances appropriately, because you can reduce your prices quite a bit when operating a warehouse. But then they will often augment their clusters quite considerably, half or more of their instances with Spot instances. And EMR will actually manage the lifecycle of those, so if they're reclaimed by the system, it will, assuming that your pricing is still in there, you can actually spin those up. And you'll see more features coming out to support that as it goes. So Amazon EMR is set up for security. The features that are, as you look at EMR, it really is built to be an environment that can be locked down through APIs, that is set up already for network isolation through VPCs and through, which is a logical isolated network that you define. So just on a network and topology level, you can use it's already set up for strong security. We also support roles, so any interaction that you want to do with the APIs, interact with S3, the data warehouse, EMR supports that. Additionally, we are pre-announcing the support with client-side encryption through KMS and also custom. So a feature that we already support in EMRFS, our S3 file system, is support for server-side encryption. So we'll be adding client-side encryption as well. How are we doing on time? I'm sorry, I don't have a clock up here. We're done? OK. All right. He gave me this, which it means get out. So that's good. So get started today, use EMR. Also check out our big data blog. You'll find a lot of very interesting articles on there, how to use R on Amazon Elastic MapReduce, how to interact with Kinesis, how to do visualization through Tableau, and how to configure and own your environment through Bootstrap Actions, and many, many more. Thank you guys for spending time with me, and I'll see you later.